Let's start with the basics. The Earth, our home, isn't as solid and unchanging as it may seem. In fact, it's more like a giant jigsaw puzzle made up of large pieces called tectonic plates. These plates are constantly moving, albeit at a snail's pace, sliding over, under and past each other on a layer of the Earth called the asthenosphere. Imagine trying to slide two rough, jagged rocks past each other. They wouldn't glide smoothly, would they? Similarly, the edges of tectonic plates can get stuck while the rest of the plates keep moving. This creates immense stress at the plate boundaries. When the stress becomes too much to bear, the rocks break or slip along the fault lines, releasing stored energy. This sudden release of energy is what we experience as an earthquake. The point where the rock breaks or slips is called the focus of the earthquake, often located many kilometers beneath the Earth's surface. The point directly above the focus, on the Earth's surface, is known as the epicenter. The seismic waves, or shock waves, spread out from the epicenter, causing the ground to shake and tremble. The strength of an earthquake is measured using a seismometer, which records the shaking in a seismogram. The magnitude of an earthquake is quantified on the Richter scale, which is a logarithmic scale. This means that each whole number increase on the scale represents a 10-fold increase in measured amplitude and roughly 32 times more energy release. Scene script. A question might arise, can earthquakes be predicted? Unfortunately, the answer is no. While scientists can estimate where earthquakes are likely to occur based on the locations of fault lines and past seismic activity, predicting the exact time and magnitude of an earthquake remains a challenge. However, understanding the mechanics of earthquakes can help us prepare for them. Buildings can be designed to withstand seismic waves, and emergency procedures can be put in place to protect people when earthquakes occur. To summarize, earthquakes occur due to the movement of tectonic plates and the release of stress accumulated along fault lines. The shaking we feel during an earthquake is caused by seismic waves spreading out from the earthquake's epicenter. The strength of an earthquake is measured on the Richter scale, and while we can't predict earthquakes, we can prepare for them. So the next time the Earth shakes, you'll know it's just our planet's way of letting off some steam, quite literally. It's a fascinating, albeit sometimes frightening, reminder of the dynamic world beneath our feet.